So anyway, they said those angles start at the 0 point over here and they go around counter. And we might have an angle right here. Remember, we refer to theta. The Greek letter theta looks like that. That is just like X, Y, or Z for a missing number. That is a variable that we use for an unknown angle or for a generic angle. This side down here at 0 degrees is referred to as the initial side. Because that's where all angles start, is from there, right? At 0 degrees. And they rotate to where they end. This side here in blue is referred to as the terminal side. Because that's where it ends. If it rotates that many degrees, that's where it ends up. Well, where that terminal side hits our circle, that point out there is uniquely defined by that angle. We talked about converting from degrees to radians for angles. On the unit circle, this degree angle would correspond to this arc length would be the radian measure for that angle. So let's say if this were 30 degrees, this out here would be 30 degrees is the arc, but the actual physical length of it would be pi over 6 radians. That's not our point today, though, to do that conversion. If you're looking at, it's not the square root of pi over 2, you're mixing up radian measure with your trig function. 45 degrees, for your sine and cosine of 45 degrees, it's the square root of 2 over 2. Yep. Your radian measure for 45 degrees is just pi over 4. So anyway, if we trace that length from that point down to that reference axis, that length is called the, anybody remember? That length is the sine of our angle. Remember, a sine is just the distance from a point on the circle to that reference diameter, no matter what point it is. But every point on this circle has a sine. Now, while we're here, a mental note you should make, there's a point over on this side that's the exact same distance away, isn't it? It has the same sine. It'll be a totally different angle, but there's a relationship between them. Whatever that angle is here, this angle is related to theta. In fact, it is theta. That is what we call a reference angle. It's a reference angle because it is the angle to the reference diameter. A tangent. What's the definition of a tangent? It touches but never goes inside. All the points are outside the circle except for the one point that touches. So the tangent, for these purposes, for purposes of our trig function, goes from the end of the reference diameter and it goes up to intersect where that terminal side would be if we extended it outside the circle. So that length was the tangent of our angle. And that full length, if we extended it out past the circle to where it intersected the tangent, is called the secant. So that is the secant of theta. Now, something you should note, what's this length here? Just the blue part? It's the radius, which is 1, yes. So that length, that radius will always be 1 unit on the unit circle. So this creates two triangles for us. This first triangle, the angle is theta. This here was our radius. That would be this smaller one right in here that I'm talking about. That hypotenuse is our radius. This here is the sine of our angle theta. And we'll talk about what the other side is in just a minute. The bigger triangle created, this one here, the bottom side is our radius, which is 1. This side was the tangent of our angle, and this was our secant, right? Sine, tangent, and secant are the three main trig functions. But your calculator has cosine on it. Where does the cosine come from? Anybody remember? Cofunctions are called. That prefix CO means complement. What's that? There's a reason why they focused on cosine instead of secant, because for certain reasons, because cosine and sine stay inside the circle, they're much easier to work with. Because secant goes outside of the circle, it's much more difficult. Tangent's actually more complex to work with as well, but we have to do something with it. So the complement, cofunctions, the complement, what does that mean? Well, cosine means the sine of the complement. So if I ask you for the cosine of 70 degrees, that is the same as asking you for the sine of, what's the complement of 70? 20. And just to demonstrate it, even though we haven't talked about calculating those functions with the calculator yet, cosine of 70 is 0.3420. Sine of 20 is 0.3420. They are the same. If those two angles are complements, the sine of one will equal the cosine of the other. So the cosine of theta is saying we want the sine of the complement of theta. Well, in our diagram up here, where would the complement of theta be? Well, this is a right angle, right? Horizontal and vertical are always perpendicular to each other. The complement of theta is this angle right here. That's why we said this is the complementary reference axis, because this is my angle theta here. All right, a little bit less squatty. That's my angle theta. This here is the complement of theta. Now, the official notation, you don't need to remember this, is theta with a line over it. That's the complement of theta. We're just going to say it's the complement of theta for right now. Its sine would be there. That's the distance back to that reference, the complementary reference axis. Well, up in this picture up here, that distance from here to there is really the same as that distance there, right? The reason I pointed that out is that means this side of that triangle is the cosine of theta. Now I can finish this picture off. The cotangent of theta would be that length. Cosecant of theta would be that length, right? CSC is cosecant. COT is cotangent. So all these trig functions are parts of the circle. Of course, they form triangles still, You remember a couple of weeks ago when we were talking about similar figures and right triangles, one of the things we mentioned is if we have right triangles, and we know that one of the angles other than the right angle is equal, those triangles must be similar, right? Because if we have the right angle and one other angle, the third one has to be the same. So these two triangles here that we got from up here, this little one and then this bigger one, those triangles are similar to each other because they have the same angle theta there. Well, I'm going to construct a third triangle here. It's also a right triangle, also has an angle theta. And we're going to name the sides of this triangle. This is the hypotenuse, right? Don't need to really give that a special name, it already has one. We're going to call it HYP for short. The other two sides were called legs. Well, to distinguish between the legs, we're going to give them a special name. The leg that touches the angle. Well, remember, we had lines that touched the circle. They were called tangent. We had angles that were next to each other and touched each other. They were called adjacent. This is the adjacent leg. It is next to our angle theta. This leg over here is the opposite leg then. It's across or opposite from our angle. Now I put the first three letters in a different color because that's the abbreviations we use. Looking at these triangles, I'm going to look at this triangle here compared to my big one over here. I'm going to start, and I highlighted those sides for a specific reason. I'm going to start over here by comparing the sine to that side of 1. So sine of theta over 1. What side of this big triangle corresponds to the same side as the sine? The opposite, so OPP. What side of that triangle corresponds to the 1? The hypotenuse. So the sine of theta is opposite of our hypotenuse. I'm going to look at the cosine in 1, which would be these two sides over here. So cosine of theta over 1. What side of this triangle corresponds to the cosine? Adjacent. And of course, hypotenuse still corresponds to the 1. I'm going to go to this triangle now. I'm going to use the tangent compared to 1. That would be these two sides over here. So the tangent of theta over 1. What side of this triangle compares to the tangent? The opposite. And now which side compares to the 1? The adjacent side. Tangent of theta is opposite over adjacent. And while we're at it, let's do secant. Secant compared to 1? That would be these sides. The secant compares to which side of the big triangle? The hypotenuse. And of course, the 1 is still the adjacent side. We're missing 2 yet. Cotangent and cosecant. That actually comes from this triangle here. Now in this triangle, horizontal lines have to be parallel. So if this is theta, this angle up here is also theta. So the cotangent would correspond to the adjacent side. And this would be the 1 right here, would correspond to the opposite side. Different orientation because it's flipped around, but it's still the same triangle. Oops, get back down there. There, I think we can see it now. The cosecant is the hypotenuse again, over the 1 would be the opposite side again. So as we pointed out on Thursday, those are our 6 trig functions. Now typically we leave off the 1 over here, but I put it in just so you can see the actual ratio of those similar triangles, similar figures. Those 6 functions should be written down somewhere in your notes. Like I suggested last week, pick the back page of your notes or something where you can get to it quickly, because we will refer to those a lot. Well, let's take something like, somebody give me a number between 4 and 20. 15 works for me. So let's say this is 15 units, 20 units, and 25 units. We'll call this angle A, B, and C. It is customary to call the right angle angle C in a triangle, in a right triangle. What is the sign of angle A? What sides are used for sine again? So you got it, opposite over hypotenuse. So for this triangle, that is the 15 over 25, or 0.6. The 25 is obviously the hypotenuse. That doesn't change. The 15, according to angle A, would be the opposite side. Which that means that the 20 would be which side? The adjacent. What if I ask you for the sine of angle B? (20 over 25), or 0.8 if we divide it out. If I'm looking at angle B here, 20 is now the opposite side, and 15 is the adjacent. So the hypotenuse will always be the hypotenuse. But the legs, the opposite and adjacent legs, will switch places depending on which angle we're looking at. That's something you have to be very careful of. Too many people get in the habit of saying, oh, this is always the opposite side and this is always the adjacent. That's not true. It depends on which angle we're looking at. What is the cosine of A? Careful. Cosine's adjacent over hypotenuse, which would be 20 over 25, so 0.8. Notice, those are the same, 0.8 or 20 over 25. The relationship between angle A and angle B, because this is a right triangle, this is obviously 90 degrees, and a triangle adds up to how many degrees? 180. So if one angle is 90, how much is left? 90. Those two angles have to be complements. So the cosine of one is just going to be the sine of the other. What's going to be the cosine of B? 15 over 25, or 0.6. Perfect. Tangent of A? Tangent's opposite over adjacent. 15 over 20, good, or 0.75. How about tangent of B? (20 over 15), or 1.333, good. How's about secant of A? Anybody remember the sides? There you go, hypotenuse over adjacent, which will be 25 over 20, or 1.25. Secant of angle B? (25 over 15), 1.667. Rounding, by the way, typically for trig functions, the value of the function themselves, we go to 4 digits. So this, we stopped here because there was one digit in front of the decimal, then we went 3 more to get a total of 4. If that would have been a 0 for the first digit, we would have kept going for another a 4th decimal place. Anybody really stuck on finding these? I know we went over them last Thursday, but it's something that I like to repeat. Well, let's look at the calculator then. If I ask you to find the value of sine of 20 degrees, you guys know how to do that on your calculator. Well, you have a key that says that, sine, sin, whatever. Most of your calculators have what's called forward notation now. Some of the older ones had reverse notation where you had to enter the angle first. But for most of these calculators, you hit the sine key, enter 20, and hit equals. If you do not get 0.342, that means you're probably in the wrong mode of your calculator. So hit your mode key and find where it says radians or degrees and select degrees. Might have to arrow down. You don't see a radian or degrees? There you go. There you go. Now, some of them have degrees, radians, and gradients. Gradients are a little bit different than radians. Gradients was their, did you get to work? Gradients was their attempt to metricize. That's why. What the heck? Oh, it's not variable, that's why. Oh. Yeah, that's better. It was throwing you into engineering notation instead of just giving you the decimal. Most calculators don't even include gradients anymore just because they're just not useful for much. So the sine of 20 degrees is 0.3420, correct? Mm-hmm. How about the cosine of 70 degrees? Should be the same. There you go, 0.3420. How about the tangent of 50 degrees? $1.192. You should have a tan key. So now the fun ones. Secant of, well, let's go secant of 70 degrees. You don't have a secant key, do you? Let's go back up here, though, and look at the definition of that secant. Secant is hypotenuse over adjacent. Do you have any other trig function that uses hypotenuse and adjacent? Cosine. It's just reverse. It's adjacent over hypotenuse instead of hypotenuse over adjacent. They are reciprocals. Secant of an angle is equal to the reciprocal of the cosine of the angle. Secant of 70 degrees is actually 1 divided by the cosine of 70 degrees. I could just do that. 1 divided by cosine 70, and there it is, 2.924. But there's an easier way of entering this that'll make it easier when we start to go the other direction to come back from them to do inverse functions. And that is a reciprocal key. Your calculators all have a key that looks like that, x negative 1. If it does not have that key, you probably have that key, 1 over x. To do the secant of 70 degrees, You're going to do the cosine of 70 degrees. And of course, it's going to give you parentheses. So you're going to close the parentheses like that. And then you're going to hit that x negative 1 key. So I'll show you. I hit cosine, put in 70, I close my parentheses, and I hit the x negative 1. When I hit enter, there it is, 2.924. That's what I had up here. So I have to remember what other function goes with it. In this case, it's the cosine goes with the secant. Then once I've entered everything in and closed the parentheses, I hit that reciprocal key. Likewise, if I do the cosecant of, let's just do cosecant of 10 degrees. If I look up here, cosecant, right here is hypotenuse over opposite. Sine is opposite over hypotenuse. It's reciprocal again. So the cosecant is really just the reciprocal of the sine of 10 degrees. And again, I could do that. 1 divided by the sine of 10 degrees. There it is, 5.789. That is the cosecant of 10 degrees. But there's a simpler way again. I can do the sine. It'll give me the parentheses. Type in the 10, close parentheses, and hit that x negative 1 again. Sine 10, close parentheses. Get my reciprocal key, and see there it is, 5.7. I put 89, so 759, sorry. 2759 is what that is. X negative 1 key. On your calculator, it should be like just above the numbers, kind of to the left side, I believe. No, this one. There it is. It's the second function of yours. You put 1 over the box. So if you do 5 and second, 1 over box, it gives you an x negative 1. Okay. So you would do sine 10, close parentheses, second, that key there. So, anybody want to guess what function cotangent goes with? The tangent, you got it. Now, this is where it's confusing. The cotangent and the tangent going together makes sense. They're both tangents. Just one's a tangent, one's a cotangent. But up here, the secant goes with the cosine. The cosecant goes with the sine. Seems backwards, but it is the way that's how it works. So you got to be very careful with those. Make sure you keep the right function with each other. That's another thing that should be noted on that page with your trig function so you don't forget it. Make sure you have that written down very clearly somewhere. That the secant goes with the cosine, and cosecant goes with the sine. And of course, cotangent goes with tangent. So the cotangent of 32, once again, we'll type in tangent 32 and then use that reciprocal key again. 1.600 is what we get for the cotangent of 32. So in your notes, I want you guys to try a few here. I want you to do the sine of 81 degrees, cosine of 29 degrees, tangent of 14 degrees, cotangent of 58 degrees, secant of 34 degrees, and cosecant of 56 degrees. Let me try those 3, we'll go over them in just a couple minutes here. Or try those 6, how about that? You don't have to count to be a math teacher, apparently. Yes, sir. Okay. Now, where's your reciprocal on that one? Good question. Take a peek here.
Is it an iPhone?
No.
No.
No. So we into this menu. No, that is not it. Holy crap, that's definitely not it. How do you enter a power in this one? We never figured that out, did we? Let's do this one.
One press the arrows.
No, that's not it. Definitely.
One press the arrows is the best thing I have to say.
Oh, you actually have a secant key on your calculator. What are you complaining about? Delete, damn you. So you hit that, and you just, rather than having to remember, you can just hit secant and type in 30 degrees.
Another problem again.
Close your parentheses. Oh, you're in a wrong mode.
Oh, I haven't checked anything up there
Yeah,
yet.
so now you gotta make sure that says degree there. If it doesn't, you push it so it says degree. But yeah, so you don't have to remember any of that crap. It always does it for you. We're going to type in 81. So that's the sine of 20. If you want the secant of 20.
What we were on
Yep.
before.
Yep.
Wherever it is in here. I just don't know what that came out.
That's right, 0.342.
That's what I was reading before.
Yeah. You just want to hit that. Now it's that's correct now. Make sure that says DEG up there.
Keep the hell out of that.
Pretty much. You get off easy with that one. So sine of 81 is 0.9877 works for me. Cosine of 29, 8746, good. Tangent of 14, sounds right. 2493, I get 2493. Cotangent of 58. 6249 works for me. So you're going to do tangent 58, then you're going to hit that second 1 over box key on your calculator. After you close the parentheses, yep. Secant of 34. 1.206 works for me. Cosecant of 56. Well, it's because they're complements, right? Secant. Yeah, 34 and 56 add up to 90. The secant and the cosecant of the complement are the same. They're going to have a little fun. So how about going the other direction? If I tell you that the sine of an angle is 0.207, how do I know what that angle is? Well, this is really an equation. I could just say the sine of x equals 0.207. It's just solving the equation. Just like if I had something like 3x equals 12, how do I solve that equation? I divided. X was multiplied by 3, so I did what's called the inverse. I divided by 3. X equals 4. Here, I have to, the variable, we've taken the sine of A. To get rid of the sine, we use the inverse sine. Now, there are actually a couple of different ways, a few different ways of writing inverse sine. The notation I used is the modern notation, sine with a little -1 there. Do not confuse it for the x -1 key. It is not a reciprocal, it's an inverse. There's arc sine, is a notation that's an older notation. Typically, if you're looking for your angles in radians, you typically use arc sine. Or just INV-SIN, inverse sine, is sometimes used. So what we're going to do here to find this, of course, on the left side, the inverse sine and the sine cancel out, just like the multiplying by 3 and dividing by 3 canceled out over here. So all we're left with on the left side is A. On the right side, though, we still have to apply that inverse sine. Most of your calculators, it's a second function. You do second sine 0.207, and it gives you 11.95 degrees. That's your angle. Did you use the second sine? We're getting the second first. Third off to the second P, then sine. Oh, they're put in point. Second, then sine. Oh, I see how yours works. You get sine. You get sine on here. Okay, double tap the sine. So if I tell you that the sine of angle B equals 1.408, find angle B for me. Yeah, I'm not very nice. If I do the inverse sine again, what's my calculator say? It says error. Why is that an error? We look at our unit circle here again, right? The sine is the distance from wherever that angle hits down to the reference axis. What's the longest that distance can be? 1. The radius is 1, so the longest it can be is the radius of the circle. The sine has to be between -1 and +1. It can't be 1.4. It can't be a -2. It has to be between those two numbers. Of course, the cosine is this distance. It also has to be between -1 and +1. You know, the sine can be negative if the point was down here. That would be a negative sign because it's below the reference axis. Tangent was over here, right? Are there any restrictions on that? No, that could go on forever. If we have an 89-degree angle, that gets way up there, doesn't it? So tangent can be any value. Cotangent can also be any value. How about secant and cosecant? Secant and cosecant have to either be less than -1 or greater than +1. They can't be between them because they're the reciprocal of sine and cosine. So the big ones are the sine and cosine that we have to be careful of. They cannot be smaller than -1 or bigger than +1. So let me give you one that can actually be done. If I say sine of D is 0.932, what is D? (68.75 degrees) is correct. I tell you the cosine of angle E is 0.318. How do I find E? So again, for yours, David, you have to get cosine twice, and it'll come up with a little cosine -1. So inverse cosine is what? 71.446, we'll call it, degrees. If I tell you the tangent of angle F is 8.24, what's angle F? 83.08 degrees. If I tell you the secant of angle A is 1.49, let's again draw a parallel here with our equations. If I have 3x minus 5 equals 7, how would I solve that equation? I would add 5, right? 3x equals 12. And then I would divide by 3. X equals 4. I reverse it. The last thing that was done building that equation was subtracting the 5. To get rid of it, I added the 5. Let's think if I calculate the secant of an angle, let's say the secant of theta. First thing I'm going to do is I'm going to find the cosine of theta and then do that reciprocal key, right? Well, if I'm going backwards, I'm going to take my value here, the 1.49, I'm going to do the reciprocal first, and then I'm going to take the inverse cosine of that. So I still do second cosine or inverse cosine. I do the 1.49, but then I put the reciprocal key inside the parentheses instead of outside the parentheses. Does that make sense? Because that's saying the reciprocal happens before the inverse cosine. Giving me 47.84 degrees. Well, it's an inverse secant, but remember the secant's the reciprocal of the cosine. So the first thing we have to do is convert this to a cosine. That's why that reciprocal key is inside the parentheses. 1.49, the reciprocal of 1.49 is 0.6711. So whatever angle has a secant of 1.49, the cosine of that angle is 0.6711. So this is a big one here to do the inverse secant of an angle. What? Yep. 0.84 to the yeah. It is 0.84. The little hamster is halfway home already for the day. So now you can probably guess the cosecant of angle B is 2.38. How would I find angle B? Well, to find the inverse cosecant, I use what? The sine. You got it. It's going to be the inverse sine, and what am I going to do with it? 2.38, and I do the reciprocal inside the parentheses. Second sine, 2.38, reciprocal, then close the parentheses. 24.85 degrees. Or if I tell you that the cotangent of angle P equals 0.099, how do I find angle P? To an inverse cotangent, I use what function? Tangent. And it's 0.099, and the reciprocal again is inside the parentheses when I do an inverse. You are correct, 84.35. 84.35 degrees. What do you think? Good stuff? Well, that's the key. Right now, I'm going to pause right here for you to remember to do an inverse cosecant. It's inverse sine, put in your number, and the reciprocal key is inside those parentheses. For an inverse cotangent, it's inverse tangent, your number, and then the reciprocal key is inside. Same with secant. It's inverse cosine, and your reciprocal key is inside the parentheses. I can't stress enough, get that written down somewhere, because in 3 days, it'll be tough to remember. Well, and in 4 days, we get a week off, which really makes it easy to remember when we come back later. You'll be daydreaming about it the whole time you're gone on spring break. Where are you heading to? So page 850 to 851 in the big book, it's exercise 33-3C. There's a ton of them there, 1 through 71, the odd. That'll keep you busy for a few minutes.